Welcome to Spring LIB.
Hi, everybody. So we have to show in distance of 10 to the negative 3, 10 to the negative 31. Meters is grand unified theory, and it's going to be equivalent to 1016 gigavolts. And for B, calculate the temperature corresponding to that. Okay? So for the unification, we have this delta x equals 10 to negative 32. Okay, there we go. I wrote there, it's 32. Okay. And then here we have the delta E is going to equal delta PC. Okay. And so to solve the P, the momentum, we have the energy divided by the speed of light. So now we have to use the Heisenberg equation. And for that, we have delta X, P equivalent to Planck's constant to 2 pi. So we're going to make that equivalent. Okay. Not equal to, but equivalent. Okay. And here, we're going to plug this in. So we have delta X, delta E, C, equivalent to Planck's constant to pi. Okay. And now we can solve for the delta E, which is going to be, oops, it's not quite equal, it's equivalent to, there we go, h bar, your Planck constant times speed of light times 2 pi times delta x. And in this, we can solve Planck's constant, 6.626 times 10 negative 34 joules per second times the speed of light, 3 times 10 to the 8 meters per second. Now we have 2 pi, and we are given 10 to the negative 32 meters. And I said 31, and I apologize. I meant to say 32. It happens to all of us. So 3.16 after you plug in your calculator times 10 to the 6 joules. And we need this into gigavolts. So we're going to do 1 V times 1.6 times 10 to negative 19 joules times 10 to negative 9 GeV 1 EV. Okay. And that's going to be 1.98 times 10 to 16 GeV. Okay. Scroll down. And now we have the D. We're going to do another equation for the D Borel formula. Okay. And here we have lambda equals the Planck's constant divided by P. And that's going to equal H over energy divided by C from the above that we did above. That's where I'm getting it. And then it's going to be HC for the wave function of E. And now we can solve for the E, the wave function, Planck's constant times speed of light times the wave function. Okay. And here it's going to be 6.626 times 10 to negative 34 joules per second times 3 times 10 to the 8 ms, okay? And that's going to be 10 to the negative 32 for the same formula that we did. And we're just making sure this matches. And we have, looks like we have all the information that's the same except for minus 2 pi. So for this integral formula, we get 19.87 times 10 to the 6 joules. And like above, we're going to have to multiply this by 1 EV. 1.6 times 10 to the negative 19th joule. Okay. And 10 to negative 9 GeV. 1 EV. Okay. And then your GeV is going to be 12.41 times 10 to the 16th GeV. And this works out because this and this are both close. So they're both close to GeV. That's okay. And I'm going to write down here, close to GeV. That's what we're going to mark there, okay? And now for B, they wanted the temperature, so we can solve that. Get T equals 2E 3K kelvins, and so that's 2/3. We get 2/3 times the 10/16 gigavolts times 1.38 times 10 to negative 23 joules per Kelvin. And we also need to convert this. So here we have, because we need to get rid of that J. So we got 10 to the 9th EV. And we have 16 EV times 1.6 times 10 to the negative 19 joules over 1 EV. Okay, and that's going to be 7.73 times 10 to negative 28 Kelvin. And that's going to be your answer, okay, guys? Thank you so much.